The time complexity of any code can be found by identifying the statement which is executed the most number of times in that piece of code. Consider this function. When this function is called, the first cout statement is executed only once. The last cout statement is also executed only once. But what about this for loop? This for loop executes 10 times and every time it prints a star. Within this for loop also, this initialization statement is executed only once. This code will not compile because the variable I is not defined, but this is anyway a pseudocode. The condition will be executed 11 times. The increment will be executed 10 times and the cout statement will be executed 10 times. Now the statement which is executed the most number of times is this conditional check. This function print star receives a parameter n, but this parameter is not used anywhere. Therefore, the execution time of this function is not dependent on any input parameter. The most executed statement is executed 11 times and this conditional check takes constant time to execute because we ignore the constant, so therefore we say that this function takes constant time. Consider this for loop. In this for loop, this condition is checked n plus 1 times because we ignore the constant, so I will be writing it n. So this condition is checked n times, this increment happens n times, and the body of loop will be executed n times. Now inside this body of outer for loop, this statement is executed n times because for every iteration of the loop, this statement is executed once. Similarly, this statement is also executed once for every iteration. So this statement will also be executed in total n times. This entire for loop will run n times. So every time this for loop runs, this statement is printed n times and this condition is checked n times. This increment happens n times. Therefore, total number of times these green statements are getting executed is n into n, which is n square. Because these are the statements which are executed the maximum number of times, so we'll say that the total time taken by this piece of code is order of n square. What about this loop? In this loop, the body of the loop is executed n times, but this print statement is not executed n times. This print statement will be executed only when n is the multiple of 10. So we can see that because this body of the loop is executed n times, so even though we'll say that this condition is executed n times, this increment happens n times, this condition is checked n times, and this statement is printed n by 10 times. But in most of the cases, it is sufficient to say that because this body of the loop is getting executed n times, therefore the time complexity of this code is order of n. What do you think is the time complexity of this code? Here, the size of the array is fixed. The size of the array is fixed as 5 and the loop is getting executed 5 times only. Therefore, the time complexity of this entire code is also constant. What about this code? This is a function in C++ that receives one parameter, and if that parameter is even, it returns true, which is 1 in C++, and if it is odd, then it returns 0, which is false in C++. No matter what the value of input parameter is, these statements will execute only once. So because these statements gets executed only once, the time complexity of this code is also constant. So we have seen that presence of a loop does not guarantee the time complexity to be linear. If the body of the loop is getting executed a constant number of times, then the time complexity of the code is constant. So we have to see how many times is the most executed statements executed in the worst case.